In the vast emptiness of space, astronomers have discovered something that changes everything we thought we knew about our galaxy. It started as a routine observation at the Very Large Array in New Mexico. Astronomers were conducting their regular survey of molecular clouds, those vast collections of gas and dust that float between the stars. They expected to see what they always saw: clouds of gas slowly drifting through space, occasionally merging in relatively calm interactions. But as they analyzed the data, something caught their attention. The numbers didn't make sense. The velocities they were measuring were off the charts. The instruments showed gas moving at supersonic speeds, creating massive shock waves that stretched across multiple light-years. This wasn't just another cloud collision. What they had stumbled upon was a cosmic hurricane of unimaginable scale. A massive interstellar storm where molecular clouds were colliding with such force that they were creating something never before documented. The temperatures within these storms reached millions of degrees, hot enough to trigger nuclear fusion and birth new stars. The storms generated magnetic fields so powerful they could be detected from Earth, twisting and churning through space like cosmic whirlpools. When the Discovery team first realized what they were looking at, they could hardly believe it. They had found something that would fundamentally change our understanding of how galaxies evolve. This accidental discovery opened a new chapter in our understanding of the cosmos, revealing that space is far more dynamic and turbulent than we ever imagined. When we talk about interstellar storms, we're dealing with sizes that the human mind simply wasn't built to comprehend. Let's start with our solar system. If our entire solar system, from the Sun to Neptune, was the size of a quarter, one of these cosmic hurricanes would be as big as Mount Everest. The smallest interstellar storms we've discovered span about 3 light-years across. That's 18 trillion miles. A beam of light, traveling at 6 trillion miles per year, would take 3 years to cross just one of these storms. But size is just the beginning. The amount of matter contained within these storms defies comprehension. A single interstellar storm can contain enough gas and dust to create millions of stars like our Sun. Imagine our entire solar system, and then multiply that by millions. That's how much matter we're talking about. If you were to travel at the speed of our fastest spacecraft, it would take you over 10 million years to cross one of these storms. By comparison, that same spacecraft takes only about 12 years to exit our solar system. These storms aren't just big, they're fast. The gas within them moves at speeds that would make our fastest jets look like they're standing still. The gases in these storms collide at speeds exceeding 1 million miles per hour. That's fast enough to cross the entire United States in less than a second. The energy released by these collisions is equally mind-bending. A single storm releases more energy in 1 second than our Sun will produce in its entire lifetime. The magnetic fields generated are strong enough to affect gas movement across hundreds of light years. These storms represent some of the largest single structures we've ever discovered in our galaxy, dwarfing nearly everything except the spiral arms themselves. Within these massive interstellar storms, we find the most efficient star-forming factories in our galaxy. As supersonic gases collide, they create powerful shock waves that compress the molecular clouds. These compressed regions become incredibly dense, up to 1,000 times denser than the surrounding space. Gravity takes over in these dense regions, pulling more and more material toward the center. Like cosmic snowballs rolling downhill, these cores grow larger and larger. As material falls inward, something remarkable happens. The temperature begins to rise, not by thousands or even hundreds of thousands of degrees, but by millions. At the heart of these compression zones, temperatures soar so high that atomic nuclei begin to fuse together. This is the moment a new star ignites, born from the violence of the cosmic storm around it. But these storms don't just create one star at a time. They're cosmic assembly lines, producing hundreds or even thousands of stars simultaneously. Each storm can contain dozens of these stellar nurseries. Some of the largest storms we've observed are producing new stars at rates thousands of times faster than what we see in calmer regions of space. The entire process, from initial compression to stellar birth, happens remarkably quickly by cosmic standards. What might take millions of years in a quiet corner of space can happen in just a few thousand years within these turbulent storms. These cosmic forges don't just create one type of star. The intense pressures and varying densities within the storms lead to the birth of stars across the entire mass spectrum. From small red dwarfs to massive blue giants, these storms are responsible for creating the diverse stellar population we see throughout our galaxy. They're not just star factories, they're the source of stellar diversity itself. But stars aren't the only thing these cosmic forges create. The leftover material from star formation collects into disks around these newborn stars, providing the raw material for future planetary systems. These cosmic storms don't just create stars, they serve as a galaxy-wide distribution system for the elements essential to life itself. Inside these storms, we find a rich mixture of elements: iron, carbon, oxygen, nitrogen. The very building blocks that make up our own bodies are being churned and transported across vast distances. When massive stars created in these storms eventually explode as supernovas, they release newly forged heavy elements. The storm's powerful winds then catch these elements, carrying them across light years of space. The turbulent nature of these storms acts like a giant cosmic blender, thoroughly mixing these elements throughout the gas clouds. This mixing process is crucial. Without it, new stars and planets would form from the same unmixed material, creating systems lacking the diverse elements needed for complex chemistry and potentially life. When new solar systems form from this enriched material, their planets inherit this diverse chemical makeup. Earth's rich composition came from material that was mixed and distributed by ancient interstellar storms. The storms transport something even more intriguing: complex organic molecules, the precursors to biological chemistry. Within the dense regions of these storms, astronomers have detected amino acids, sugars, and other organic compounds. These molecules are the fundamental components needed for life as we know it. The magnetic fields generated by these storms create vast channels through space, like cosmic highways that guide the movement of enriched material. These storms often form interconnected networks, creating a distribution system that spans entire spiral arms of our galaxy. It's nature's own delivery service, operating on a scale of thousands of light years. Every star and planet system in our galaxy bears the chemical signature of these great storms, including our own solar system, making us all children of these cosmic tempests. The discovery of these massive interstellar storms has forced us to completely rethink our understanding of how galaxies work. Our old models of galactic evolution portrayed galaxies as relatively calm systems, with stars and gas moving in orderly patterns. These storms reveal a far more dynamic and chaotic reality. We now know that magnetic fields don't just passively exist in space. They're actively shaped and amplified by these storms, creating vast networks that influence galactic structure across thousands of light years. Perhaps most surprisingly, these storms show us that galactic change can happen much faster than we previously thought possible. Processes we thought took hundreds of millions of years can occur in just a few million years within these storms. They're accelerating galactic evolution in ways we never imagined. The storms reveal an intricate web of connections between phenomena we once thought were unrelated. Star formation in one region triggers storms in another, which then influences magnetic fields that affect gas movement elsewhere. It's a complex dance of cause and effect spanning entire galaxies. These storms don't just shape their immediate surroundings, they influence everything from the rate of star formation to the distribution of heavy elements, even affecting the potential for life in different regions of the galaxy. The implications extend far beyond our own Milky Way. We're now detecting similar storms in other galaxies, suggesting this is a universal phenomenon. These cosmic hurricanes appear to be fundamental to how galaxies evolve and maintain themselves. They're not anomalies, they're essential features of galactic structure. Every new observation of these storms reveals more complexity, more connections, and more questions. We're just beginning to understand their full importance. Today, astronomers around the world are dedicating themselves to studying these phenomena, knowing that they hold the key to understanding some of the most fundamental processes in our universe. As we continue to study these massive interstellar storms, one thing becomes increasingly clear. The universe is far more dynamic, interconnected, and amazing than we ever imagined. Thanks for watching, and remember to subscribe for more mind-bending space discoveries.